First problem based on the viscosity is, viscosity is property of a liquid due to which it, and there are the four options. We know that viscosity is property of a liquid due to which it opposes relative motion between its adjacent layers. So option B is the correct options. If we check other options, option A is occupies minimum surface area. This is a property of surface tension. So option A is incorrect. Option C says that it becomes spherical in shape. It is also the property of surface tension. So this option is also incorrect. And option D is tend to regain its deformed position. It is the property of elasticity of the body. Hence option D is also incorrect. Second question is, a liquid is flowing in a streamlined manner through a cylindrical pipe. Along a section containing the axis of the pipe, the flow profile will be. We are given the cylindrical pipe, and for cylindrical pipe we know that the velocity is 0 at the boundary, and this velocity is maximum along the axis in cylinder because of the viscosity. We know that viscosity is the property in which there is a position of the relative motion between the adjacent layers. So layers at the boundary have 0 velocity, and this velocity increases as we move from boundary to axis, and it becomes maximum along the axis. So from given diagram, option D is the correct option because at boundary velocity is 0. As we move along the axis, suppose this is axis, velocity gradually increases and becomes maximum at the axis, and from axis as we move down towards the boundary, again velocity decreases and to the 0. So option D is the correct option. Third question is, three identical vessels A, B and C are filled with water, mercury and kerosene respectively up to an equal height. The three vessels are provided with identical taps at the bottom of the vessels. If the three taps are opened simultaneously, then which vessel is emptied first, whether it is vessel A, vessel B, vessel C, or all the three vessels get emptied simultaneously. Here if we consider the ideal situation in which there is no effect of the density and the viscosity, in that case velocity of efflux through the hole of the container will be root 2 gh, where h is the depth of the hole from the surface of the fluid. Because in all three cases this velocity of efflux will be same because h is same, therefore all the three vessels will be emptied simultaneously. But if we consider the effect of the density and the viscosity also, viscosity all the three cases are very small, while the density of the kerosene is very small in comparison to others. Therefore, the effect of density will be dominating and the kerosene will be emptied first, and answer is the option D, that is vessel C containing the kerosene will be emptied first. Fourth question is, water is flowing on a horizontal fixed surface such that its flow velocity varies with y in vertical direction as v equal to k2y square by a square minus y cube by a cube. If coefficient of viscosity for water is eta, what will be shear stress between the layers of water at y equal to a? We know that viscous force has the value equal to eta into a into dv by dx in terms of magnitude. This implies that shear stress, which is the force per unit area, that is F by A, will be equal to eta into dV by dx, where eta is coefficient of viscosity and dV by dx is the velocity gradient. This is equal to, because here velocity is changing in vertical direction which is y, so we will write it as eta into dV by dy. V is given that k into 2y square by a square minus y cube by a cube. To find the dv by dy, we have to differentiate the given expression, which is k into 2y square by a square minus y cube by a cube. It will be equal to k is constant, it is taken out, and now differentiating the terms, that is 2y square by a square minus differentiating with respect to y to the y cube by a cube. It is equal to k into 1 by 2 by a square is constant, it is taken out, and differential of y square will be 2y minus. Here 1 by a cube is constant and differential of y cube will be 3y square. So it will be equal to k into 4y by a square minus 3y square by a cube. So replacing the value of dv by dy, we will have eta into k bracket 4y by a square minus 3y square by a cube. Now we have to find the shear stress between the layers of the water at y equal to a. So shear stress F by a at y equal to a will be equal to eta into k into, now replacing y with a, we will have 4 into a by a square minus 3 into a square by a cube. Simplifying, it is eta k 4 by a minus 3 by a, and it will give eta k into 1 by a. So finally we will have eta k by a. Hence option A is the correct option. Fifth question is, spherical balls of radius r are falling in a viscous fluid of viscosity eta with a velocity v. The retarding viscous force acting on the spherical ball is. From Stokes law we know that retarding viscous force is F equal to 6 pi eta rv. So viscous force is proportional to radius of the ball and it is also directly proportional to the velocity. So we can conclude that option B is the correct option, that retarding viscous force acting on the spherical ball is directly proportional to both radius r and the velocity v.